Hi class, this will be part 2 of your Blended Learning Day, 9 February 2022, where we'll be looking into AM textbook page 26, practice now 8. Okay, we'll be learning how to solve this kind of questions, and I've highlighted the key important words for each question. This is how we dissect the question. Okay, for part 1 of question 1, find the range of values of h for which the line does not intersect the curve. I have highlighted does not intersect the curve. You should be able to visualize for me how the line and the curve look like. Since it doesn't intersect, you must be able to tell me that there are no real roots. And what can you tell me about my b squared minus 4ac? It is actually less than 0. Okay, so this is how we dissect the question. And we look at part 2. Part 2, I highlighted the word tangent. Yes, you haven't learned tangent before. I'm just telling you that tangent means the line will intersect the curve at one point. So there's only one real root. And hence your b squared minus 4ac. You should be able to tell me that it is equal to 0. Okay. The last one, how do we dissect it? Okay. The range of values of p for which the line intersects the curve. Keyword is intersects. Did I tell you how it intersects? Is it 1 point or 2 point? It can be either 1 point or 2 point, right? It can intersect at 1 point or intersect at 2 points. So it can be either 1 or 2 real roots. It's not limited to just 1 or 2 roots. Okay? So if it's 1 or 2 real roots, basically it has real roots. And b squared minus 4ac, you should be able to tell me that it is more than or equal to 0. Okay, so keywords are all here, and this is how we have dissected the question. I'll be zooming into question 2, which I've done halfway in class. Question 2, okay, find the range of values of p for which the line intersects the curve. And you are given lines, okay, line, linear, and quadratic. Okay, so before we actually use discriminant, we need to come up with the quadratic equation, right? Before you use b squared minus 4ac. So first of all, you write down the two lines that I am working on. Okay, my line and my curve. Okay, label them as 1 and 2. And we are actually finding possible solutions, okay, to actually come up with the quadratic equation as we have done in part 1 of Blended Learning Day. Okay, we will be equating both of them together to find solutions. Basically, 1 equals to 2, I use substitution, which will give me 2px plus 9p equals to x squared minus 4px plus 9 bracket p squared plus 1 close bracket. Okay, from here, I should be able to come up with the quadratic equation again. Quadratic equation, okay, to find my a, b, and c. So please rewrite it as a quadratic equation form. Okay, do you get the same answer as me? Okay, I actually got the final step here, where I've written it in a squared plus bx, ax squared plus bx plus c. I hope you're able to tell me what is my a, what is my b, what is my c. Notice that my a is 1, b is negative 6p, and c is actually all my constants, 9p squared plus 9 minus 9p. Take note that p is a constant. P is just a number, so just treat it as a number. Okay, and as mentioned, our b squared minus 4ac is more than or equals to 0. So just sub into ABC, sub ABC into that. Okay, please try it on your own now. After carefully substituting my b and my a and my c, b, a, and my c, okay, into my b squared minus 4ac more than or equals to 0, okay, because it intersects, okay. And after I substitute it, okay, simplify it, you should be able to get p is more than or equals to 1. And we have answered the question, okay, because we have found the range of values of p for which the line intersects the curve. Okay, so as long as my p is more than or equals to 1, the line and the curve should be able to intersect. Okay, so now it's your turn to try page 27, AM02B. I have two similar questions. Take note of what are my keywords. Okay, please tell me what is my b squared minus 4ac and try out the question yourself. Okay, using the same method. You should be able to do this. All the best.